Question 10 says in the diagram below, OPQL is a parallelogram. It said OP, we have our vectors. We have an algebraic vectors here. OP is equal to R, OL is equal to S. I hope when they bring vectors tomorrow, because vectors gonna come anyways, like certain things always come. I hope you'll get numbers, but this one wasn't that bad. Because sometimes they could bring these algebraic vectors so complicated. But again, OP is equal to R, OL is equal to S. T is the point such that PQ, vector PQ is equal to vector QR. PQ, where is QR? Okay, QT. Oh, okay, okay. It said the point M divides PL into ratio 2 to 1. Yeah, we get to that where we need that. Yes. So this says we're not gonna need no calculator for this right now. So I might as well just open up the screen because we have algebra in it. They want us to find in terms of R and S vector PL. PL. Hmm. We need to create a vector equation for sure. PL. Where's PL? From here to here, right? Means we starting from P, we ending at L. Um, we could go from P to O and then continue from O to L. But do we have PO? Yeah, we have OP. We can work with it as the opposite vector. So we can start from P to O and continue from O. We have OL. Bravo. So always remember when you're creating a vector equation, the first letter, sorry, that's an alarm I have there. The first vector starts the equation, the first letter in the vector. The second one ends it. Whatever letter you have in the middle has to be the same. Otherwise, you have an error. If you are doing addition, like how I doing addition of vectors. Okay. So, can anybody tell me what is vector PO? If vector OP is R, what is PO? Hmm. You'll need to remember
Minus
opposite.
R.
Okay. Yes, so that is absolutely correct. Minus R is good. So yes, it's minus R because this one's positive and then OL is positive S. So add the S. And that's the answer right here. So this one was straightforward. And no wonder they put 1 mark. Anyways, the next one, we have OM. OM. Let's see here. Where is OM? OM, OM. Okay, we have to connect that. So OM. We could either go from P to O and then from P to M, or we could go from O to L and L to M. Which one should I do? Well, which one do I know? Well, I definitely know OP. I also know OL. Do I know PM? They said M divides PL in ratio 2 to 1. Hmm. Do we know PL? Oh, we just found PL. Good, good, good. So it don't really matter what reason. I think I go in from O to L and then from L to M. You could go from O to P as well and then from P to M, like using the same information. So we're going from O, common stuff, not tonight, OL. We continuing um from L to M. Now, based on the fact that they give us this ratio, that's to help us, right? It means that from L, we could add the numbers in the ratio, right? 2 add 1 is 3. So it means the bigger part from P to M is 2/3 of PL. And from I think I'm going to change my equation, but just now from M to L is what? 1/3. Now why do I want to change my equation? Let me see if I should. What if we just from PL? And if I go from L to M, I can still figure it out, but I have to do opposite vectors. I don't want to forget. So I'm changing my equation, okay? But we can still use it. It's just be like an extra step. Main reason why I change it, we just from P to L, right? Where the vector starts from P and ends at L. So if I go this way instead, I wouldn't have to find no opposite vector. But if I go the other way, L is going opposite, then heading down to P, even though I'm trying to get LM, I'll have to find the opposite vector. So to avoid that, that's why I changed it around. Okay, yeah. But I could have stick with it, but in life sometimes it's good to find the easier way out. And it's math, so why not? Okay, so OP plus L. Okay, OP is R and PM is sorry, put the wrong number there. Is 2/3 or a fraction, of course. 2/3 of PL. So we can work that out on the side somewhere, working column. Yeah, all these alarms I have on. So PM, vector PM is equal to uh a half of negative R plus S. Ooh, I like how this going over the diagram. Just take that off for now so it looks visible. Half of negative R is negative a half R. Half of positive S is positive a half S. Like there's nothing much we could do here. So the next thing I'll put is R minus a half R add a half S. Now the only reason why we kind of leave our answer like this is because they said they want the answer in terms of R and S. Now you want to be but the answer of R and S. But normally when they say that, but they didn't say to simplify either. So just now. We could leave it like that. They never said to simplify. Or if you want to take it a step further, you can leave it like this. Or if you want to simplify the r's using algebra, we have r, which is 1r, minus a half r. Both of them are terms, and r, one take away a half is, well, a half, it will be positive a half r. So you can also simplify it. If they say to simplify, simplify. If they don't say to simplify, you don't have to. Plus 1 half s. So that is the answer I'm getting here from, what was that again? OM, vector OM. Oh, I make a mistake here. What is going on with me? It's not a half. Where did I get a, Lord Patel, where I get a half? It's supposed to be, so I just have to change the fractions to 2/3. Where did I get a half from? What is this? So it's just 2/3 I have to change it to. Because I like a half. How I know figure out this I put in the wrong fraction. What have mercy. So this here, this will have to change for sure. Um, that's now. I'll have to change it from here and see what else I need to fix. So that's why I good to double check. I'll put it back half again. I'll put it back half. like a half or what? So you put in 2/3. This would have been plus 2/3. So that would have been correct. It's just to change that to 2/3. Here now, when we take 1R and 2/3, that will change for sure. That will not give us no half of nothing. So 2/3. Um, this here, right, can also be written as 1 could be written as 3/3 because we deal with a fraction that have a denominator of 3. So we can write 1 as 3/3. R minus 2/3 R. Taking away their numerator because they are like fractions with the same denominator. 3 take away 1 is, sorry, 3 take away 2 is 1. They will have the same denominator. So the correct answer is 1/3 R. Is there anything else I need to change? 2/3 S. So I need to change the S coefficient from being a half to 2/3. You'll see what happened here, right? Those things happen. It happened with me. And it can happen with anybody. So that's why it's good to double check. Um, just to make sure you did everything correct. Because I put in a half, like where I get a half from. Okay, so that's the answer from OM for vector OM. 1/3 R plus 2/3 S. What's the next one? It said prove that the points O, M, and T are collinear. Collinear means they're on a straight line. I mean, they're on a straight line, you know. What is one you say again? O, M, and T. Where's O, M, and T? O, I'm taking all this because it's blocking the diagram. O, M, T. Oh, okay. I need to take all this too because it's blocking. If we draw a straight line, we could tell they're on a straight line, but they said to prove, so we have to do something in addition, right? But just to draw a straight line to show from O connected to M and R, they're on a straight line because all their points are definitely on that line. So what we have to do, one of the things we can do to figure out that they are collinear, which means they are on all of them on the same straight line, like how I drew it there to show visibly. Um, we could find um let's know or we could find if we find empty, we'll figure it out. Vector empty. Because we already know OM. Did we just find OM? So the thing with collinear vectors to prove it using vector like calculations, one vector tends to be smaller or larger than one, or have a scale factor. Like yesterday when I was doing the transformation question with the enlargement, you would have seen that the diagram, the image was twice the size of the object. So it's something similar like that where if you look, we don't know what the scale factor is right now, but I could figure it out. OM is smaller or shorter in length than from M to L. We could literally see from M to T, sorry, is longer. So MT is probably 1.5 or twice the size of OM, but we have to prove that to show that they are collinear. So collinear again means they are on the straight line because that's what happens with vectors. On the straight line, they tend to be either twice, half, something the size of the other one. So we could find MT to figure out, oh, how do we find MT? From M to T, that is So hold on, hold on, hold on. We try and clear up some of these things from here. I wouldn't need this part, but I'll need OM. So I'll leave OM on the screen, clear everything else that is irrelevant. Okay, um, right. Put among this stuff here. This one going to be a very weird one, because vector equations, you might have seen most of the times when we do vectors, for those who learn vector sessions. A lot of times you could create very short vector equations, but this one going to be a little longer because in order to go from M to T, we starting from M. Okay, so MT, right? We starting from M to L. Okay, we're going from M to L. Then we continue from L to Q. Yes, kind of weird, but that's what we have to use. We have to use what we have. And then we continue from Q to T. So it's like a longer, slightly longer vector equation, but that's what we have to use to get from the beginning to the end. So just like any other vector, you always start with the first letter, you end with the second. The letters in the middle here, L and L. The letters in the middle here, Q and Q. You have to make sure that the middle letters are always double when you add it, like how I have it. So, um, using that information, we're going to do what we got to do. Do we know? That's not hold on. Do we know ML? Oh yes. So before I was saying that this is 1/3 of PL, but we don't know it exactly, but we could figure it out. So it's 1/3 of vector PL. I just took off PL. Oh my goodness. You will tell me in a moment, please, what PL was again. LQ is do we know LQ? Oh, where's LQ? Oh, we know OP. And since it's a parallelogram, these two would be parallel and equal. So this will be R as well. Yeah. But it actually said PQ. Where's PQ? Is equal to QT. Oh, that's for the next part. But yeah, since O to P is R, from L to Q is also R. So this will be R. And then they said here, uh PQ, this part, is equal to QT. What is PQ? Did we find PQ before? Did we? I don't recall that just now. Let me check below. PQ. No, we never find PQ. So now we have to find PQ. That's what's going to make this a little longer working indeed. So we find, okay, we don't have to because they give us OL. So better yet, less working. Because I would have to go and do a whole vector equation. Another one. So if O to L is S, from P to Q is also S. They start around the same position, heading down. They're heading in the same direction, so they'll be same S. They're not in opposite direction. So that means from Q to T will also be S because they said here that vector PQ is equal to vector QT. So we add S. The only vector we need to work out here is this one. You all need some assistance, please. Can somebody tell me what was PL again? I think it was negative something. Uh, what was that again?
PL was minus R plus S or S minus R, the wait later.
Yes, thank you. So, minus R and S. So 1/3. That'll be negative 1/3 R because we multiply 1/3 by everything in the brackets, and then positive 1/3 S. Okay, so we could rewrite this as negative 1/3 R add positive 1/3 S. And we still have R here and S. We need to simplify it though. We have two terms in R, two terms in S. Because if we don't simplify it, it'll be difficult to tell if they're really collinear. So we need one term in R. So what we really have there is 1/3 negative, sorry. I'll leave out that negative sign. And R is 1R, okay? Why put that negative sign there for? It should be here. So one takeaway, 1/3 is 2/3. 2/3. And this was an R. I left out the R. And both of them are terms in R. So I got thus far 2/3 R. What else? What else? What else? 1/3 S. 1/3 S. We have common stuff. We have two terms in S as well. So we can work them out. I'll work it out over here. 1/3 S plus S, which is 1S. Okay. 1/3 and 1 is 2 1/3. Sorry, no. That can't be 2 1/3. That's 1 1/3. What's going on? 1 1/3. 2 1/3. I might run ahead of myself. 1/3. I put back the S. So that will be. I don't think I want to leave it like this. I think I prefer to write it as a improper fraction. One. If I need to change it back, I'll change it back. But 1/3 is 3 and 1 is 4/3. 4/3S. Okay, plus 4/3 S. Okay. So based on the answer I have now, they want us to prove OM. I know the screen full of stuff. From O to M and M to T are collinear. Okay, we look at them, right? For the R's. The R's sell it out real good. If you look very closely, right? I don't know if you'll see what I'm seeing. Let me see if I could take off. Stop, I'm giving me trouble again. Uh, I'll see if I could take off like the unnecessary additional things, right? What we want to look at right now is OM, vector OM, and vector MT, which are on the same line, right? The same straight line, which means they are collinear. How can we prove for sure they are collinear? Look at the terms in R for both of them, right? This one has 1/3. This one has 2/3, which means for MT, R is twice, because 2/3 means 2 1/3. This has 1 1/3. So MT is definitely twice. That's one indicator that's given us twice. Because in order to get 2/3, you have to say 2 multiplied by a third. If we break it up like that, you get 2/3. So MT is twice. Now, even if you look at the S as well, we see the same thing is going on. Look at the term in S for both of them. One of them have 4/3, 4/3. The other one has 2/3. The 4 means it is twice the size of the 2/3. Because in order to go from 2/3 to 4/3. Trying to write this thing properly, but okay, much better. To go from 2/3 to 4/3, you have to multiply by 2. 2 by 2 is 4 over 3. So it is definitely true that O sorry, OM and MT are collinear. They are on a straight line. They are on a straight line. Because one is twice the size of the other. I hope that's clear, okay? If you have any questions, then we'll let me know. So that's how we could prove that they are collinear. One tends to be twice or more times or less times the size of the other. Okay, so let's end with this matrices and call it.